Greetings all of you. My name is Teacher Junji Isaac. We are looking at the R formula, and now we are going to look at the minimum and maximum value with the help of the R formula. So we have two parts in this question. One part is telling us to find this maximum value and minimum value of this, but this is a reciprocal. And now we have a maximum value of this expression also. So let us look at part A. So what we are going to do is to write this. We convert this into other form. This is R. I'm going to use cos x plus alpha. Let me use minus alpha. Then there is a constant, so I'll add a constant here to be equal to 5 cos alpha cos x plus 12 sin x. So let me expand this. There is a negative 10. So let me expand this. Definitely our a is negative 10, but now let us try to convert these two terms as a single trigonometric ratio by finding r and alpha here. So if we expand this, we shall get r cos alpha cos x, then plus, because when there is a minus on cos, here we use a plus, then we can get r sin alpha sin x. So we are now comparing plus a. So if we compare, our a is negative 10, then our coefficients here on cos x, we have r cos alpha equal to the coefficient here is 5. Now the coefficient on sin x is 12 on the other side, so we have r sin alpha equal to sin alpha will be equal to 12. So let us find the angle. Tan alpha will be equal to 12 over 5. Alpha is going to be tan inverse of 12 over 5. So our alpha will be equal to, let's see, the tan inverse of 12 by 5 is giving us 67.4. So 7.4 degrees. So now let us look for r. So r, what we have to do is to get the square root of 5 squared is 25 and 12 squared is 144. So our r is going to be equal to the square root of 169. So we get r as 13. Plus or minus, we shall use the magnitude here. So in that case, we have 1 over this one here is going to be 13, then cos x minus our alpha, which is 67.4 degrees. Now, how can we find the maximum value and the minimum value of an expression? So we know that the cos varies between -1 and 1. So we shall take the cos of an angle to be -1 and the cos of an angle to be 1, then to see what we get. Then we shall be able to conclude this was -10, the maximum and the minimum value. So let us first take our x the angle, the cos of an angle to be 1 for cos x minus 67 to be 1, and is cos x minus 67.4 to be equal to 1. Then what do we get? This will be 1 over 13 times 1, then minus 10, which is 1 out of 13. Then from that we are going to use a negative 1, the cos of this angle here to be negative 1, (67.4) to be equal to negative 1. That means we shall be having 1 over 13 times negative 1, then minus 10. We shall get 1 over negative 23. So by looking at these two values, the maximum is 1 over 13 and the minimum is negative 1 out of 23. Maximum is equal to 1 out of 30. So these are the two answers for this part A. So always convert this to the other form, use the other formula. But now cos varies between 1 and negative 1. The maximum value of cos is 1 and the minimum is negative 1. So we shall just replace the cos of an angle with the 1, we get the value. Then we repeat, when the cos of an angle is negative 1, we get the second value. Then we compare the two, which one is maximum and which one is the minimum. Simple as that. So let us go to part B. So part B, this expression can be written as R. Now let me use sine this time. Sine x plus alpha. Since I have a constant, let me put my constant there. To be equal to 3 sine x plus 4 cos x, then plus 7. Of course the constant will be the 7. Now let me convert these two terms in this form. So by expanding this, I'll get R sine alpha cos x, then plus R cos alpha sine x plus our constant if I expand the left hand side. So if I compare now, the coefficient of cos, I have a 4, and the coefficient of cos here I have R sine alpha. So R sine alpha is equal to 4, and R cos alpha is equal to 3. If I compare the coefficient of sine, I have R cos alpha equal to 3. So what is alpha and what is R? So that we write our expression for K is already 7. So R will be equal to the square root of 4 squared plus 3 squared, which is 16, plus 9, 25. So our R is going to be equal to plus or minus 5, and we shall now focus on the magnitude, that is the R. Now what about the alpha? Now alpha, we shall divide the two. 1 divided by this. If this is my equation 1 and this is equation 2, I divide R, this up here, I'll remain with tan alpha. So tan alpha is going to be 4 by 3. So tan alpha, or alpha, will be equal to the tan inverse of 4 by 3. So alpha is going to be, let's see the tan inverse of 4 by 3. Of 4 by 3 we get 53.1 as our alpha. So now from here we need to rewrite it. Write this part. So our R is 5, then sine x plus alpha equal to, no, plus a constant k, which is 7. Now even sine ranges from -1 to 1, so we shall begin with 1. For sine of an angle x plus alpha to be equal to 1, we shall be having 5 times 1 plus 7, which gives us a 12. That is one value. Now for sine x plus alpha to be equal to -1, we shall be having 5 times -1 plus 7. This gives us a 2, because this is -5, implying that our maximum value is going to be 12 and our minimum value is 2. So that is how we do such numbers. So thank you for watching. So we are going to meet in part C for question 11, where we find the maximum and the minimum value of the expression. Please subscribe to the channel, hit the notification bell, and recommend the channel to your colleagues. We're still making more videos.